from the Red Hat network. Now this Yum repository, again, can consist of RPMs from various sources, again, including the Red Hat network, so you could use one subscription to publish updated RPMs into your local Yum repository in your network environment, and then allow your other Red Hat servers to benefit from that local Yum repository. Even if you had a subscription for each Red Hat server, it would be less than ideal to have each of them connect using HTTP to Red Hat servers for bandwidth reasons. So to conserve bandwidth, download the RPMs once and then set up a Yum repository. Let's consult the shell to see if we've made any progress. We're up to 2 gigs, so we still got hundreds of megabytes to go. Let's see where we are now. 2.4, we're almost there. Again, this is being pulled using LFTP with the HTTP protocol across 100 megabits per second backbone. Let's check again. Now we're at 2.5 gigs, we should be finished. And indeed we are. So let's exit this LFTP session. It's 2.5 gigs, it hasn't changed. Now we need to create repo. That's a step where we indicate the full path. We'll copy this command, which will create the meta files. This is scanning through what appears to be just under 2160 packages. Again, the packages will not be changed. In fact, from the other shell, if we lsltr the Yum repository, we'll see that the packages are intact with different timestamps, but a new directory, repo data, has been created. We're just over the 10% mark. And we'll continue to elapse the progress in the interest of saving time, so we're over 20% of 2159 packages. Again, the packages will not change, just metadata will be added that we can then transfer to the source server. We could even use the original source repository, but just to keep things clean, we've decided to double up on the repository, but we could have used on the SUSE box, for example, the i386 server location. That's this location that we've been accessing thus far. It could serve dual purposes for Yum as well as for general RPM installations, but if it is a Yum repository, then there's no need to RPM followed by, or execute RPM followed by an RPM HTTP URI. We could simply use Yum space install space the name of the package, and Yum would go about finding it. So we're just about wrapping up the create repo process. Just a few more files to go and we should be ready to move forward. Saving primary, file lists, and other metadata. And now the process is finished. Let's echo the exit status. That didn't take too long. It wasn't so bad. And a duch of Yum reveals that it's still 2.5 gigabytes. However, we did mention that the new entry, the directory entry that is, the repo data entry, has been created. We can publish this data, or this data directory, back to the prime repository and then just update our yum.conf. That's one way to go about doing it. So for example, let's get a little creative and use tar. So let's just change things a little bit. Instead of RH5 Yum, we'll continue with RH5 i386 server as our source path. And then we need to publish the Yum repository using HTTP. So what we'll do is create a tarball out of the rep data directory, repo data that is, directory. We'll use bzip version 2 compression, so CJVF. We'll call it yum metadata.bz2 for the path repo data. This will create a file in the current directory, then we'll copy the file to the foreign server. And this will be ready momentarily. It's further attempting to compress an already compressed file. That's lsltrh yum underscore metadata. It's 8.8 megabytes. So now let's SCP this file to the SUSE box, which is located at 192.168.75.100, into serve www.linuxcbt.com, RH5 i386 server. We'll specify the password. And it indicates that it's read-only because the remote system has the directory mounted. In fact, a mount will tell us that the ISO image is indeed mounted. So the easy way to fix this issue would be to create a new structure, yum, and then copy the files on the remote system and then unmount the ISO image. So let's copy it into RH5 yum. Then we'll have to change our configuration slightly. So this will copy into yum, and then on the remote system, in the interest of saving time, we'll copy APVF i386 server, and in fact we just need the RPMs, so no directory preservation. Start RPM to this directory. This will copy the 2.5 gigs very quickly, and then we'll update our notes once again. Instead of i386 server, because we forgot we earlier mounted the ISO as opposed to copying it, it will be RH5 yum. We'll just confirm locally that the yum.conf file is in place. So let's nano etc yum.conf, and it is indeed RH5 yum. So the original path still applies. We'll be referencing RH5 yum as opposed to RH5 i386 server. And then we'll extract in RH5 yum the repo data file. So while this copies, let's open yet another session to the SUSE box from one of our empty windows. We'll SSH to 192.168.75.100. It will prompt us for authentication. Then we'll navigate to serve www. Again, we're doing all of this because Apache is running on the SUSE box and serving content from serve www.linuxcbt.com. So it just makes it easy for us instead of having to set up Apache on the local system. So here's the yum directory with the RPMs that have been copied, but there's also the yum metadata file. So let's tar xjvf yum underscore metadata, which will recreate the repo data directory and its file list and other XML files that the yum client will reference. So now an LSLD of repo data reveals that it's there. And so long as the web server is able to read the directory, it doesn't have to own it, we should have no problems accessing it from the yum client. Let's take a look at the total space occupied, and 2.2 of 2.5 have been copied. Local disk I/O copy is always faster than across the wire. So this will be done momentarily, at which point we can finally test yum from a client perspective to install a package. Let's say, for example, locally we will install GFTP. So let's ensure it's not installed. RPM query GFTP, and it's not installed. Let's confirm, and it's now 2.5 gigs, which means the copy process should be over. And it is. So now that we've copied all the files, let's just ensure that our yum.conf configuration is complete on the first server. Now we've set the base URL. There are two more variables that we need to set before we forget, and that's an ID, a unique identifier for this repository, and you can use any string, but we'll just use a numeric 0001, as well as a name for the repository. We'll call it Linux CBT SUSE 1. Let's go ahead and paste this, and we just need to point to the top level directory where the repo data can be found. That's the important directory to point to on your HTTP server. So on our local system, Linux CBT serve 1, we'll nano etc yum.conf and be sure that we have that in addition. And we'll remove the last item. And now we should be good to attempt to search for packages. So how about searching for GFTP, that is? So yum usage 1, search for packages. For example, yum search GFTP will search for GFTP from the repository after having set up the repository. Let's navigate to the shell and give this a try. This will attempt to set up the repository with all 2159 packages. And by the way, if you make changes to your repository, rerun create repo to update the XML files. RHN support is disabled. However, this first or 0001 repository is in the process of being set up. And there it's found GFTP 2.018-3, and it tells you it's a graphical FTP client. A search allows you to perform a search, doesn't install it for you. However, to install a package, use yum install. So install package, or packages, we'll install a couple of them. Yum install GFTP is one example. Let's give this a try from the shell. And this will prompt us for installation momentarily. Sort of works like apt-get in the Debian environment. We'll indicate Y to install, and momentarily we'll have the package installed. Now it tells us that the public key for the RPM is not installed. We've yet to import it, and that is true. Let's grep IGFTP from the query list, and there it shows that it's failed because we don't have the public key. But this we can override. However, it makes sense to import the GPG key so that packages can be confirmed. Let's show you where that key is. Instead of i386 server